The side event is called Transformative Climate Services for Decision Makers based on observational data. We have talked a lot about observational data in the last days. You might have been at the Earth Info Day where many observational data have been introduced. You might also have followed the research and systematic observation negotiations which have been concluded last night. And we heard, as I said, a lot about observational data, about the necessity. We want to turn around the viewpoint a little bit. And we want to ask how can we organize the observations as following demands from climate services. So we are also partly reporting about a project, an EU project called CADI, which is looking a bit on climate services and observational necessities in Africa. And the basic of this project was that we have turned a bit the value chain. Usually we as scientists think we have a value chain from observations via science, via assessment into the climate policy, but here we want to start from the societal processes. For example, the societal process of the necessity to act against climate change, and the respective requirements, the respective questions that are coming from science, from societies to science. So we starting this cycle on the right side. Go from societal requirements to the knowledge generation, to science, and then we find out specific requirements towards research infrastructure. So what is the observational research infrastructure that we need, and what are the data that are useful for generating services, which then go again through science and to societal services. So we don't have a straight line value chain, we have more some kind of an interactive circle between societies, science and scientific research infrastructure. That's our approach for this meeting, for the observational data and looking at observational data. And I'm very, very happy to have a lot of speakers here in our side event, and I would like to start with the person at my right hand side, Niina from the University of Turku, and on my left hand side Zakaria Njirera from Tanzania, from Dar es Salaam, and he is one of the chairs of the so-called Resilience Academy, and he's also a professor at the Agric University in Dar es Salaam. Welcome.
Thank you.
And these two will start our session, and they will work or will tell you about the approach in Tanzania or in Dar es Salaam. That's called the Resilience Academy. They are both geospatial scientists, and I think that's very important because climate change is, or climate observations, they are important for, or you need a sense of place for that. They are happening at a specific place, and that's why it's really important to have geospatial sciences in that. Niina, I would like to ask you first to give us your presentation.
Thank you, Werner, and good afternoon, ladies and gentlemen. I'm very happy to be here from University of Turku, Finland, with some notions regarding co-creating transformative climate services for African cities in particular. If I first tell a bit about the context. I mean, Africa is urbanizing extremely rapidly. By far, majority of Africans are urban dwellers in the future. This means that the future of African climate adaptation will be solved in the cities. If we can't make it work in the cities, it's not going to work elsewhere either. Because of the fast-growing pace of the urbanization, there are some risks which are quite big barriers for sustainability at the moment. Cities are growing largely in an unplanned, uncontrolled manner, and there's an in-migration of enormous amount of people to cities. We have deficit in getting access to reliable risk information concerning physical infrastructures, concerning social, cultural infrastructures, nature, and so forth. At the same time, Africa's urban future is full of opportunities. There's a young generation growing there, and this young generation is going to be increasingly educated, and there's an enormously growing digital infrastructure in Africa at the moment. It's very important to ask what type of job opportunities, future opportunities these youths will have. Now, I've been particularly interested, and in the Resilience Academy, what my colleague Gereja will soon tell about, we've been excited about this disruption space that happens between growth of globally open, increasingly accurate spatial data about our environment, about our climate, about different parameters. At the same time, we have artificial intelligence, machine learning, and different automation technologies that enable us to harvest information out of this data. But there's a major challenge. When we scale climate services to urban level, we really need locally validated information, which is contextually relevant. It's not the accuracy issue in terms of spatial data, it's about whether the data means something in the context of the people who live in the cities. Citizen science is giving us a very prominent way of working in this space in a manner where we actually co-create new ways of thinking, how we can improve access to climate risk data, understand better how digital public assets, such as digital open data sets, open tools, technologies, could be turned into better informed decisions in the cities, by the citizens themselves, by the authorities, by us who are working on the science side of the coin. Now, for the last 20 years, we've been working closely with different stakeholders in Tanzania. So my notions come from that learning space that we have had together. We worked with different co-creation processes where we've tied the science approach to that of the practical approach. And what we would like to claim here, and what our KADI project in terms of urban climate services is particularly interested in, is that how we can combine the digital data tools, youth capacity building, youth engagement into socially and culturally sustainable climate services. I would even rather say that it's not the digital domain where the revolution happens, it's the social domain. If we can make contextually fit for purpose digital climate risk data and tools, then we are able to embed them into the ways of living in the future African urban environments. In KADI project, we have so far identified that, of course, any observation system is based on scientific knowledge about those weather parameters or climate parameters we are interested in knowing and measuring, but those are not enough alone, because the context is changing so fast. We need geospatial data of the cities themselves, and currently we have inefficient ways of measuring the change. We can do that much faster if we scale our approaches, those digital tools and technologies, with the help of the youth, those thousands and thousands of youth who need opportunities for job and learning, into the co-creation processes of up-to-date risk data, which then, as a coupled benefit, gives also job opportunities for this new generation. I would like to finish my talk, and we can go back to this in the panel, that as a scientist working closely with institutional cooperation with our African university partners, I really have been thinking lately, what does it require for us to practice open science in a 21st century way, so that we, at the same time as we do top research, we also do learning, skills development, and societal cooperation, not by dissemination, but doing it together in a way that we have a bottom-up approaches and engagement of the societal stakeholders into this into this climate service co-creation process. And those are the matters which I would like to share a bit more in the panel later on. Thank you very much.
Thank you, Niina, and I'm sure we will discuss this in the panel, but I would like to ask you one specific question. You mentioned the citizen science and the new approaches, so can you have perhaps one practical example how citizen science methods can be used in the co-creation of climate services?
Sure. I mean, I give you a couple of examples. One is that when we have global, let's say, Earth observation-based data sets, for example, we can utilize the power of the young people to validate these data sets and make them contextually relevant in terms of the information content. We made a very exciting trial during COVID 2020 together with the World Bank, where we put 140 young people 2 hours a day to do micro-tasking on mobile phones to validate photos of urban infrastructures throughout the world. They were collecting 170,000 observations in 5 weeks' time, and that data set was used by the German Aerospace Center to produce Global Settlement Footprint, which is a 10-meter resolution data of the urban infrastructures of the city. With the machine learning techniques, that can be repeatable. But we cannot do that if we don't have a reference data, validation data locally collected. Another example is that the communities, when we engage communities into a co-creation process, we actually indirectly make them to understand what is the power of knowing their own assets in the local connection where they are living. We can measure the heat. We can say when the heat is too much. But it's another thing to say when the heat is troubling my life. And it's not about numbers, it's about the feeling and the experience. And citizen science, coupled with actual measurements, is an extremely powerful way to turn the science observations into an actionable knowledge, with local knowledge integrated.
Thanks a lot. Zakaria, you are dedicated by passion for geospatial data. And you are one of the leaders of the Resilience Academy. So can you please tell us about your approach and about the way how you are collecting geospatial data and how you are using them for a transformative approach?
Thank you. Resilience Academy is a 5-year project. I can say that for the last 5 years, Tanzanian universities, University of Turku from Finland, and the World Bank has been co-creating an innovative and community-driven partnership and service delivery program, which is called Resilience Academy. And this program aims to improve climate risk management through involving of the youth and university students in turning their digital skills as well as their competencies in the area of geospatial data collection. And our philosophy or the strategy that we have been using is to think that we need to know that the future climate services and the data production models requires that these procedures to be localized. They should be locally driven, low complexity, but also fit the purpose of the context and they engage the local talents, especially the youth, digital skills, and the competencies. So the core idea is to use the affordable and the locally adaptable digital tools and the bottom-up community engagement to transform skills into climate risk data collection, management, and decision-making. How do we do this in our Resilience Academy? We have 4 core areas that are interrelated in the local actions and the services, which you can see on the screen. First, through engagement of the community, university students, non-government organizations, and the companies in data collection to address the knowledge gaps so often faced in data scarce societies. So we call this mass internship model. The second one is through climate risk database, where the collected data are deposited or curated in a disaster risk database. And all these data that are collected by students and our other partners are part of the open data repositories. But also through Resilience Academy, we have e-learning resources which provide an opportunity for students at universities to use and practice our methods. The last one is based on research and innovation, which enable ecosystem and actors, data blocks, tools, and learning assets to be used by as many people as possible. So this is like a living lab for anyone to join and speed up and discover new and impactful digital data solutions. The Resilience Academy has a lot of impacts for African universities and the students, and these impacts can be reflected from two sides, from students' reflections as well as community perceptions. From the student reflection side, we can see that there has been increased practical skills in working with digital data and the tools, as well as better recognition of climate risk and the capacity to safeguard most vulnerable local assets for adaptation and mitigation, both safety and security. Another one is on the spatial awareness and the local living spaces that allow improved cooperation, preparedness, and conflict resolutions. On the other, on the side of the community, there has been increased awareness of climate risk and the disaster issues. So that is how we do in the Resilience Academy.
Thank you very much. I think this is very, very fascinating. And also to you, a question that goes more into the concrete work. I really like this risk database. This idea is really interesting. And could you tell us a little bit more about the data collection and the specific practical examples what you have collected with your students for this database?
Thank you. Through the mass internship program, where youth and university students have been engaged, a lot of geospatial data sets have been collected. Through the disaster risk database, we can see a lot of data that has been collected. For example, solid waste for the municipality, to manage waste better in the cities, and the collection of soil data, which are then used to model and improve flood hazards. There is also data collected related to tree canopies to estimate the better green vegetation impact for the city, heat stress, and also trash data collection. Those are just examples of the many data sets that have been collected by students.
Thank you very much, Zakaria. And I think no, I pressed the wrong button, I suppose. But while the technique is helping us, we are going to the next speaker, and that's Johanna Masic. Johanna is the Global Lead for Sustainable City Infrastructure and Services and Lead Urban Specialist at the World Bank. And we have talked a lot about money for observations, so I'm very happy to have you here. And I think you want to give also some insights
Yes.
about this kind of observations.
Yes.
Please.
Thank you, and hello everyone. So I'm here representing our Global Facility for Disaster Reduction and Recovery, and in particular my colleague Edward Anderson, who's not able to be here. who has been supporting this Resilience Academy over a number of years. And I wanted to explain a bit more why we see this as a really important effort that has potential for scale up elsewhere in the region. We know, as Niina said, data is lacking. These are fast-growing cities. 90% of urbanization will happen in Africa and South Asia. And cities in the continent, African continent, are growing 5% in surface area every year, and it's happening at a pace that it requires much faster, more nimble data that's regularly updated, because the impacts in terms of the urban footprint, both on emissions but also on resilience, because this is happening in risky parts of cities, is really critical. And what we often see in our investment projects when we're looking at understanding risk, we're hiring international firms who come in and do the same kind of work over and over again. And so that's why we see this as something that we've built on actually 20 years of history that has already happened through academia that doesn't happen easily. So it's something very important to build on, and then we have to think how to make that more sustainable now. This type of effort that leverages low-cost digital solutions, that localizes data, services and expertise domestically in domestic institutions, but also I think community organizations and community groups that understand the climate risks and the very real disaster risks that they do face. And it also allows better coverage of this kind of data services than we would typically have. But obviously there's the potential to match this with global observation, but this is really the ground truthing, right, in practical reality. And I think for our side, it's how can we continue to build on this experience as a kind of a model or a lab of how to do this and take this beyond Tanzania to other places and to share your experience with other countries that we're working in. Thank you very much.
I think this connection between global and local observations are really, really important, but let's stay for the moment at the local observations. So what do you think is are the key data services or key topics that cities need for becoming more climate resilient?
Well, I think, we've just been in sessions today. The issue of urban flooding is coming up over and over again. Obviously, increasingly urban heat, air pollution, solid waste interacts with urban flooding. So how do we use these kind of data services seem to be the sort of top issues that are affecting people on a day-to-day basis.
We in ICOS are also running another project that is observing the emissions out of a city.
Yeah.
So what about mitigation? How can you support cities who might be the most important players in mitigation as well? How can you support them with climate services for mitigation?
I think Tanzania is one example where the capital city, a lot of the emissions is coming from wastewater that's sitting, it's actually methane emissions from stagnant utility treatment. So from our side too, understanding city level emissions, and in the case of the African continent, the work to collect bottom-up inventories, data collection is a very heavy process, and we need to find much faster and quicker ways to really understand emissions and monitor and track them and verify them, because then there's the link to the climate finance.
Thanks a lot. And we are going on, and we are now going from Tanzania to Kenya, and we are very happy to have Joyce Kimutai on the panel as well. Joyce is a climate scientist from the Kenyan Meteorological Service, and her research is increasingly focusing on the analyzing of climate research and also on the co-production of climate services. And she will talk us about a city pilot in Kenya, in Nairobi, and I'm very curious about your work.
Thank you so much for that introduction, and also thank you for having me on this panel today. And thank you to the attendees and the participants in this side event. I'm excited to talk about the city pilot in Nairobi. Yeah, so Nairobi is Kenya's capital. It has close to, it's actually has over 5 million people living in that city. But something very interesting about this city is that it's quite diverse actually in terms of sort of the kind of settlements that exist in the city. And you find that quite a majority of people live in what we call informal settlements, so slums. So, and what you see, I don't think I can point, but it's really the first picture and the second picture. A lot of Nairobi residents live in these informal settlements. And these informal settlements are quite vulnerable. So, I mean, the city itself is quite urbanizing, actually. So there's really big influx of people coming to the city. And you find that majority of these people find themselves in the informal settlements. And with this city pilot that we're carrying out, we really decided to do climate services for informal settlements. And we thought it was going to be very interesting to look at heat, which we think the perceptions are quite low. And for an African continent, for sure, is that it is quite undocumented. Its impacts are quite undocumented. Its early warning systems don't exist as much. And in most countries, they really, Met services, they don't have any early warning system that triggers any warnings for heat. And you find that it's mainly coming from like there are no clear usable definitions of heat that have been used. And so in this particular pilot, what we want to focus on is on really starting to determine what are the thresholds that we can use, what are the definitions of heat that we can use that are usable for the people in the region. And we want this really to be guided by the user needs. So we want to engage these communities living in informal settlements. We want to ask key questions of what is really important to them, what are their heat perceptions. And so we think really citizen science is key. So that sort of bottom-up approach is really key because we want to make sure that the services that we provide at Kenya Met really serves these people. So to us, co-production is very key. And we want to really prioritize as well dissemination of that information. We want to understand what are the channels that exist in this community in a way that they can receive this heat information early enough that they can use to make their decisions. And so really this project will build a lot as well from what is happening in Tanzania. So we'll have a lot of exchange on what is already happening, borrow a lot from the citizen science initiatives that are happening in the city of Dar es Salaam that we can actually adopt in the Kenyan city as well. Yeah, thank you so much.
Thank you very much, Joyce. We have now seen 2 examples, and there are many, many more cities, not only in Africa, globally, and there are small differences, but there are also commonalities. So how do you think that Earth observation can address the global disparity of the local needs, but also the common, other common approaches, for example, to tackle hotspots or other things on the city scale? So what's your idea or your approach on that, also at the Met service, to look at the different needs of cities?
Yeah, I mean, So for cities, really, I mean, it's really the information has to be relevant. So it's very context specific and location specific. So a city like Nairobi would be very different from a city like Mombasa, for example. And I'm talking from a point of, I'm borrowing from the experience of a project that I led last year. So it was a small project that I was actually, so most of the work that we'll be doing on heat will be really borrowed from the experiences from that project. We looked at 3 cities in Kenya, Mombasa, which is really the coastal city, and Kisumu, which is near Lake Victoria, and Nairobi. And we could, as much as there were like really similarities in how we would engage the communities there, there were quite a number of disparities as well, in a way that we needed to engage them deeper to provide very relevant and context-specific climate services to them.
Thanks a lot. We have to rearrange the podium a little bit. So we have Tuukka Petäjä from the University of Helsinki here, but I would also like to ask to the stage Clément Albergel from ESA, and I will make space for you. We learned that we had invited too many people for the stage, so the moderator has to leave now. And we are going into other ways of observation now, which is not so much anymore on the citizen science, but also connected to that. So I would like to welcome Professor Tuukka Petäjä from the University of Helsinki. He has over 20 years research experience related to experimental atmospheric science and atmospheric observations. He's the Vice Director of the Institute for Atmospheric and Earth System Research, and he's also responsible for the research in aerosols. And that's a new topic, a new question. And he's also very much involved in long-term observations and research infrastructures. So Tuukka, can you please give us your view on city observations and perhaps bring also the air quality as a new aspect into the discussion?
Thanks, Werner. Yes, so I will expand a little bit on the scope of climate observations, because one of the parameters that is linked to climate is the atmospheric aerosol particles, which have influence in climate, both warming and cooling effects, but it has a very direct consequence for well-being of citizens in urban areas. So air quality is dominated by these small suspended aerosol particles, and this is more and more important in the future. Niina already showed what happens in the future. This is just a different view on this. These are the megacities in the world at the moment, 25. But if we go forward to 2100, we see that big cities, I would say gigacities, particularly in Africa, are emerging, and this is where the climate change has high impacts, but it's also the well-being of the people. So the people living in the cities will be responsible for CO2 emissions, but also they are affected by the air quality from their emissions and also nearby emissions. So we need to address this together with climate change, so the well-being of citizens within the urban areas. And actually what happens in the very large cities is that they form their own environment, and we can, the emissions that in terms of air quality are emitted at the ground, at the surface, what we've seen by analyzing data is that these emissions actually stay in the lower boundary layer, and there's a vicious cycle that actually deteriorates the air quality even further. So the local activities and emissions really make air quality worse. So this is something that needs to be addressed. One way of addressing this is super sites, or these very comprehensive observations. And it's very important to make the observations together with greenhouse gases and aerosol and air quality parameters in a co-located manner with harmonized methods, because it's critical to get data that is comparable. But these observation sites typically are not in the urban areas, not in the cities, not where the people live. So their exposure is not known. So we need to scale and understand what's happening around these super sites, and then we need these kind of sites in the urban areas. But also what we can offer is to connect to lower cost sensor networks operated by citizens or volunteers to map out the picture in the region, and also connect to the satellite observations, which provide another view on the spatial variability. So that's it. Thanks.
Thank you, Tuukka. I think connecting your presentations with the presentation with the previous presentations brings me to one point, and this point is that when we want to have citizens science and observations, we need, I think, a new generation of sensors. We need sensors that are easy to handle, that are low cost, and so on. So what do you think, what part does the frugal innovation plays in transformative climate and perhaps also air pollution sciences and services?
Yeah, I think you can turn this into a question that quantity over quality, or which one is more important. I think in this case both. So what we need to really make sure that there is collaborative work that connects the technologically developed lower cost sensors with the data that is measured in the super sites, so that we can build with the AI applications and things like that, data platforms, we can build calibrations for the low cost sensors, and that improves the quality of data. And for citizens and people living in the cities, it really opens the eyes that they can actually have an influence on their personal exposure if they have a good enough quality instrumentation that their choices in life and choices in the where they travel can reduce their personal exposure, and that should be connected to also their feeling and personal feeling of the environment they are connected to. So it's not only about the numbers, but it's also the feedback that comes from that being less exposed to air pollution, smoke, feels better the next day. So kind of connecting these. Okay, so we add the air pollution also to the risks, to the health risk and to the personal risks, in addition to the climate risk. The last speaker, before we go into a more discussion style, is Clément Albergel. He is a scientist working at the European Space Agency. So we are now going into space and looking back down to the Earth, and he will tell a little bit about remote sensing and the use of remote sensing. He's working in the UK in the Climate and Long-Term Action Division of ESA, and he is focusing on land surface activities. He has before been at ECMWF, the European Center for Medium Range Weather Forecast, and at Météo France. So he has a long record in climate sciences and developing services. And please give us your view from space.
Thank you very much, Werner. Very nice introduction. Thank you. The United Nations Framework Convention on Climate Change, UNFCCC, is leading the global effort to combat climate change and keep global warming well below 2 degrees Celsius as set out in the Paris Agreement for Climate. UNFCCC is the body responsible for driving global climate action. But in order to take decision on climate adaptation and climate mitigation, the UNFCCC requires systematic observations of the climate system. Satellite Earth observation has the unique capability to provide global coverage, to provide uniformity, rapid measurement, and continuity. As a doctor with its patients, they permit to take the pulse of our planet, to scan our planet. But I would like to say and to highlight that satellite Earth observation are complementary to all other sources of information, in situ measurement, measurement from drones, airborne, buoy ships, to build a much needed global integrated observing system. We need satellite observation, we need in situ observation, and we cannot use the fact that we have satellite Earth observation at global scale not to invest in situ network. The UNFCCC needs observations. It has delegated to the Global Climate Observing System, GFDRR, a public consultation to define a list of variables that represent climate at best. GFDRR developed a list of 55 so-called essential climate variables, ECVs. More than 2/3 of them can benefit from satellite Earth observation. And as a direct response to the UNFCCC needs in observation, the European Space Agency has developed its climate program, the Climate Change Initiative, CCI, more than a decade ago. The CCI is a coordinated research and development program amongst ESA member states that main objective is to develop global-scale, long-term, robust, satellite-derived key component of the climate system, the essential climate variable. To date, we have 27 ECV projects developing 27 ECVs in the different compartments of the Earth system. And we do that by putting together, by harnessing 40 years of ESA Earth observation archive and combining them with data from third-party missions, missions that are not operated or owned by ESA, and current missions such as the Sentinel. All those data is freely available on the internet for everyone to download. Just for sake of example, one of the essential climate variables we develop is about soil moisture, and it is by stitching, by putting together data from 17 sensors up there, or that are not up there anymore, that we have managed to develop a global data set spanning from 1979 to 2022. It is also available following this website. And I also wanted to say that our work is very complementary to the one of operational climate services. We work with them for complementarity and synergy. We collaborate on common research and development and provide pre-operational development for operational climate services. 16 of our essential climate variables were demonstrated to be mature enough to be transferred to operational service and are now backed up by the Copernicus Climate Change Service and EUMETSAT. And we further collaborate with them on interoperability, quality assurance, data provenance, and user information. Thank you.
Thank you, Clément. I think you referred very well to the essential variables, but I would also like to go a bit more practical. So, can the satellite Earth observation also help, for example, countries with their national greenhouse gas inventories?
Thank you for the question. Satellite Earth observation enable global climate research by providing timely and accurate information in large quantity about the Earth. And it's only when combined with societal information that they can provide vital knowledge about risk, resilience building, opportunity. We mentioned national greenhouse gas inventory, and we were just before this session in a session talking about cross-checking national greenhouse gas inventory from space. Yes, satellite Earth observation can help to reduce uncertainty in national greenhouse gas emission inventory. They can help to identify additional emission reduction opportunities and provide nations with timely guidance towards progress, the emission, toward progress regarding the emission reduction strategies and pledges.
I have a question to Zacharia. also related to satellites. Is the Resilience Academy also using spatial data from satellites?
Yes, Resilience Academy uses Earth observation data from satellite, especially those available from Open Data Portal. For example, from the European Space Agency, the Sentinel data especially, yeah, and from the USGS data, Landsat.
Thank you very much. That's very nice to hear. I'm a climate scientist, and most of my activity relates to implementing the climate change initiative program of ESA, but I'm also involved in different activity with the EU Africa initiative, where we try to leverage the use of satellite Earth observation in Africa. We are developing with the Ministry of Agriculture and Rural Life in Kenya a vegetation drought monitoring system, and we are also looking at developing a drought monitoring system in South Africa in collaboration with the Department of Water Sanitation and Sensor. And on top of that, I also work on a program on international development called GDA on climate resilience, where we work with the international financial institutions such as the World Bank. We've been in some meeting together,
Yes,
I think, to develop this type of activity.
Thank you.
Joyce, do you want to comment on this from the Kenyan Met Service point of view? How are you using satellite data?
Yeah, so we definitely using satellite data. I mean, it's important to have diverse data, right? I mean, to especially compare the different performance or the analysis or validate some of the products that we do. So yeah, we definitely use that. But it'd be very interesting to hear what you're doing. You said you're collaborating with Kenya on that. So it'd be interesting to chat about that on after this conversation.
We will do.
Good, we can tick a box that this side event already has built a network. Well, we are all developing or aiming to develop services, and I think this is a good approach to, but also a challenge for scientists to a bit leave the comfort zone, because services need co-creation. So my question to all panelists, and we might start with Johanna and then come along, is who is for you or for us the most important customer of the services that we are developing?
That's a good question. I mean, the ultimate customer, of course, are the people living in the cities that will benefit from these types of partnerships and data. But as you said, it's necessary to better link the scientists and the academia with the citizens and the community groups to make sure that that really does benefit our intended audience. And I wanted to maybe just also give a short example, if I can, that we do work closely with the European Space Agency. They have a secondee to the World Bank over time. And we started the Digital Earth Partnership recently as well, which really, I think the point is that these types of interactions need to be supported by networks like the international financial institutions, academia, and our client countries, Tanzania and Kenya, we have here. It's really an organized partnership, and we all benefit, I suppose. Thank you.
Zakaria.
The beneficiary of the Earth observation data are the community through the local governments, because the local government need this data to help them to inform decision making and for planning, but also universities, because they need this for research, and the various research that are conducted using Earth observation data, they can also now inform the community as well as the government and the local government in a number of issues related to climate, to disaster, and the urban greening, and so forth.
Clément.
Thank you. Yes, I agree. It's really citizens and decision maker. In a way or another, we are already all using satellite information. And I think we need to open the dialogue. If we stay between the scientific community and the space agencies, we are talking to each other. We know what we are talking about. We need to develop more link, for example, with national greenhouse gas emission inventory. It's very nice to develop very beautiful platforms with satellite Earth observation. But the most difficult thing is to bring this information to decision maker and to citizens. We need to use satellite Earth observation for efficient policy making and policy implementation monitoring.
Niina.
Yeah, perhaps to first say that, of course, the climate service ecosystem is a multi-actor ecosystem, and it means that every actor in that system has a different reason why they are there and what do they need from those services. So there is no kind of one right end user, but everybody's a user and everybody's is a kind of an actor who gives something for that ecosystem. Of course, as an academia, we have to think of the generation that we are training, because those are our immediate beneficiaries within the institutions where we work. And we need to think of these benefits when we co-create something that we engage our students. We don't think that they're not experts enough, but they have to become one. And the only way to get them there is to get them engaged from the very beginning. And that is our mission. At the same time, I would like to think that if we do things at the academia without understanding what is the demand, then it's a bit tricky thing. So we only push things, we say that our knowledge is important, our skills are important, but we don't create the users for those skills. So it's really about the interactions, and that's why this, like Joanna mentioned, the Digital Earth partnership between the bank and European Space Agency and the different actors in that operational space have to work together, because otherwise we don't get these incentives in structured way planned and executed.
Joyce.
So for Kenya, for the city pilot, for us really the goal is to, and I think something that would be success for us is actually really speaking to those informal people living in those informal settlements, like providing services that are actionable to them, that they can use, that they can be able to be used by the policymakers as well. People don't make decisions there. And one big goal that we have with this initiative is developing IT action plans. So, which will maybe come later. It may not be part of the work that we're doing currently, but I think eventually it will help us further such in interventions or in incentives. And I think an important thing as well will be like really to leverage on the existing networks that we have with those communities, create new networks, co-produce this information, listen from them, learn from them, make sure that whatever we're providing is the information that they relate to and they can be used by them.
Tuukka.
Okay, I think quite a lot of things have already been said, but since the task was to identify one, so I identified one, and it's the middle level. So if we think that from the kind of each country, there's national government making decisions, but the key thing is that how are different action plans or plans to go forward implemented then within the city level. So my answer is actually city level actors and decision makers, because they need to implement what is done in the country level, and they also are in direct connection with their citizens and trying to improve the well-being of the citizens, and also pushed from the citizen point of view that something has to be done to improve the living conditions, improving air quality, and improving solving climate crisis, and so in a way city level actions, and then what we can offer in terms of research infrastructures and science is tools for that, and data to monitor how the for example green transition or improved air quality or climate actions have worked, which haven't worked and which have worked, and so the city level governments and decision makers can then make a choice that this seems to work, we do that. So that's kind of my take on that. Thanks.
Well, most of us are scientists and educated as scientists, different generations of scientists. I might be an older generation of scientists who has been educated a bit more inside the ivory tower. And I always feel challenged by this task of co-location. So it needs a different mindset. So who wants to help me and describe the necessary mindsets for developing these services, for being really transformative and for also developing these citizen science and open science approaches? Any suggestion?
I can go if it's breaking the ice. So I think from my side, we need data that addresses very locally specific issues, but it also needs to be scientifically robust, right? So it needs to be both, and it needs to be affordable and scalable and at the right time. So that for me, I think this type of discussion here is exactly the kind of conversations that need to take place.
So there's still some space for me as old
I think
school
so. I think
scientist.
you're okay.
Can I respond quickly? That I think one of the key aspects or the mindset is really the openness for interaction and collaboration, because there's not a single discipline in science or different group of people involved in the society who can solve this by themselves. So it has to be this willingness to openly discuss and develop the tools together. So I think that's kind of the way forward, in my opinion.
Joyce, you want to comment?
I was going to say exactly. I mean,
Sorry.
no problem. I mean, key for me is really co-production. I mean, having worked at the Met Service for some time now and providing forecast or climate information to the people, what I've really come to understand is the importance of co-producing that knowledge or that information with them. So, and it has to be a feedback loop, right? It has to come. It's all the way. If a part of that loop is broken, you're definitely going to miss something, and it means that there's either information that is either broken, or there's lack of understanding, or people are not communicating with each other, or there is lack of understanding of particular aspects that are very important to that whole process. So I think really what is key is listening to the communities that you want to provide the services to. And I think the most important should be even further than that, it should be more of demand driven. They should be the information that they want. And you should have really taken a bit of your time, some effort to service the needs of those people. So you really understand what they require, what they need. So that whatever you're giving them, it's really a bottom-up approach, as you said, that it has to come from them going up. Otherwise, you might just as well produce a service that will not be used or be useless to the people.
Niina or Zakaria, do you want to comment?
Well, perhaps just to say that I think there needs to be a lot of appreciation on the different knowledge systems and their integration. We cannot push the world to think like a scientist, but what we can do, an effort, is to operate between the knowledge systems that are existing in this world, and therefore largely I feel that the bottlenecks are there within appreciation of the humanity side of and the social side of the digital transformation that we have. We have all the tools now. We do have also much better access to data, but have we actually discovered the way we can make cultural and digital and social capital to meet in a way that these tools and solutions become actionable? So scientists, as a kind of a new generation scientist, which I don't think I'm either, but I feel that the next generation has to realize that they have to be brave enough to to listen to what the other knowledges are, and then find the magic between these knowledge systems, because that's where the triggers, that's where the keys are.
That was exactly my question. Can you elaborate more about your ideas of bridging between the different knowledge systems?
Well, like I earlier on said about the citizen science thing, it's not only about putting citizens to produce data at all. It's about engaging people so that they can bring their knowledge system into that co-creation process, and we all value that because their interpretation of the world is really that demand what we are talking about. We don't know what the demand is. We may think we know, but we don't. And I feel that this bottom-up, time-demanding, dedicated science is the one that can only do it at the end. Because it's not, if you travel somewhere in the world once and you talk with locals, you think you know what they think. No, you don't. You have to live with with people coming from different backgrounds. You have to understand. You need those knowledge brokers who are there. But it takes time, and sometimes I feel that we live in the world where incentivization of doing science is far too short-sighted. We have project 2 years, 3 years. Where are the outcomes? And I always think that embracing process upon those results is more important eventually, because we need to have that bridge between various funding instruments to look at the evolutionary side of the coin. And it's not, but we just don't have time anymore if we think of the crisis, and that's why it's so critical that we do these things better than we've done before.
Zakaria, I think this climate risk database, which has a lot of local geospatial data, but I think also a lot of scientific knowledge, is one example for a bridge between the different knowledge systems. Am I right?
Yes. My thinking is that what we get from this science and from all the data that we collect after processing needed to be translated into a simple way, simple language that can be understood by the community, and how the way we disseminate this information to decision makers should be in a simple language to be understood by the decision makers.
If I may even add on that, I think somehow the digital data is still, I mean, it's extremely valid in terms of producing locally relevant spatial data that helps us to do the risk assessment or climate service design where observation data and contextual data are linked. But we should appreciate the fact that the knowledge systems which are not using directly this data are still using the information and knowledge which is embedded in this data. The local communities may not need that spatial data to act, but since they've been part of the co-production of that data, they have that internal map and acknowledgement of their assets in a spatial form, in an appreciation form, and that data has become a transformative language of their knowledge to those decision makers and scientists who then use that data. So it's kind of like that, if you cannot have a language of science, you can visualize your knowledge into a language of science via data, which then others can take forward. And this is quite intriguing because we need those codes that take those knowledges.
And from the very beginning, you need to feel that you are concerned and involved in all those activity. And spatial data are very important because when you look at a map, you can say, oh, I live here and this is happening there. In the past 2 summers, we had a lot of wildfire following a period of intense heat. And in France, we talk about that with a lot of people. They say, oh, before we were looking at fires in California or in Australia. Oh, wow, it was far. But now it's in Gironde, and I can see my town close to this big, scary burn area. You need to feel that you are concerned. I started to be interested in meteorology when my father installed the rain gauge in our garden. Before that, I didn't pay much attention.
We have now talked a lot about knowledge system, about mechanisms to get information. I would like to introduce a new round on the topics. We had already heat, air pollution, and also floods. Could you elaborate a bit more on potential services or potential risks or topics that you see where these services could be developed? Perhaps we start this time this way with Tuukka.
All right, so I'll break the ice. Actually, in terms of development of new tools, the most intriguing approach that I can think of is actually making a combination of the tools, because if we look at only heat by itself, or the floods, or the air quality, I think we should we can be in the situation when we are either consequently experience different hazards, but also at the same time. So having this kind of a combined effect, which is more than the sum of parts. So that would be my 2 cents on that.
Okay. Joyce.
Yeah, so first, before I talk about the tools, I wanted to just comment a little bit on the complementarity of different knowledge systems. I mean, you really have to appreciate other knowledge systems that exist. And I would talk, for example, of indigenous knowledge. I mean, for you to say that this particular service can be useful to you, I mean, you need to understand, how do they understand that kind of service? Or even just how have they been coping with these impacts, or understanding their environment in the way that you think can be useful. So I think it starts with complementing what you know with what they know, so that you can enrich that information. So I think that is very key. And in Kenya, for example, that has really helped us deliver climate services. In the past, we would just create a forecast, and then we give it out to the people. It's like we're telling them that this is what needs to be done, or this, you expect this much rainfall, or a drought is coming. And for them, they are not even ready, or they have their other forms of knowledge that they interpret the climate. And they're not likely to listen to us, because they're like, all of a sudden you're coming with this information, I was supposed to interpret this information. But when we changed that, so it was really a mind change, a change in mindset. And what we did is we started conducting, we call them participatory scenario planning. So before the season starts, we engage with these communities. We have them either in workshops or just other forms of engagement that we would find important. At one point, we had community radio stations where we reached to them, but that is more on dissemination. But I just mean on the sort of the co-production and trying to understand what they're doing. So when we like expecting a drought, we would say, what forms of knowledge do you have? How would you understand this drought? Have you seen what we're seeing? Our forecasts say this. What do you say about this? And that was really, we learned a lot from that. But just to talk about the tools, I think a multi-hazard early warning a multi-hazard climate service, or a tool that can really be able to deliver services that combines sort of needs, or especially when you talked about these compounding events. I'm thinking of heat and drought, and it would really be nice to have a tool that can incorporate all that and be able to deliver, because you can't have them in separation, right? When a drought is occurring and when a heat is occurring, you can't have them, you can't separate them. So you find even like the impacts are compounded. So you would want to have a service that can actually serve that, can provide the needs, can be able to handle that kind of compounding nature of that asset.
Yes, it is obvious now that many of these services we are now referring to are not actually a single service, but there are a constellation of services and change of reactions that are happening, and particularly when the context is rapidly changing in the background, it seems that whatever we design as a service then is outdated by the time it's invented, just because the context is changing rapidly. So we need to be adaptable to that. One element that I'm pretty intrigued is the biodiversity service domain, which is there, also interlinked to our capacity to also control these immediate hazards that we've been now discussing. But I somehow feel that this urbanization and biodiversity loss and degradation is something which is not so easily visible and identifiable, but which is there in the background and is causing a lot of let's say, weakening of our capacity to manage these risks. Not directly by erosion and stuff like that, but also like our exposure to microbial things over our lifespan. When we become urban dwellers, what type of resistance we have towards different diseases and stuff like that. And how do you measure that? I mean, it's much more complicated service, but it's very much related to what we are talking about here and where the urban context is really facing.
Maybe 2 points on that. First, on what Niina just said about having services or a constellation of services, we also have to be careful. Talking to decision makers and economists, I think they can handle uncertainty quite well. What they have difficulty with is having the same information provided by 20 services, because then they cannot really understand what to do. And I think that's something we've been discussing at this COP, is also the need to build indicators. Indicators, for example, for climate adaptation. And we've discussed that with Joyce, I think 2 or 3 days ago in the Global Cafe or the Earth Information Day. Going from microwave to land surface temperature is not enough. We need to go towards developing indicators, for example, in town of urban heat discomfort index. And this way, for example, we will be able to even put a price and look at the monetary impact on investing on a town, on developing a blue or a green zone, and I'm not talking about COP, in a city. So we can say that I have invested that much in my green zone here, and I've managed to improve my index by this much. We need to develop indicators to be able to track the impact of adaptation.
If I contribute with an example from the Resilience Academy about the services that we have co-created, specifically the disaster risk database, where a lot of data, useful data stored there, that this service has been very crucial and important for the citizens, for the community, as well as for the university, because they are required. And the local government also requires data. Where do they get data? So the Resilience Academy has provided these services so as to enable users, various users, the local community, the local government, even research institutions and the universities, to use this data so that they can produce useful solutions based on the available data that are freely available and can be easily obtainable through the disaster risk database. But also another service is e-learning asset, where a number of courses and the mini-MOOCs has been co-created, and these benefits a number of students from universities, and the academic staff also can use these e-learning assets to improve learning and the practical in their various courses offered at the university level.
Maybe just one sentence, because I know we're out of time. I think everybody's mentioned the additional tools and topics, but I just wanted to emphasize the importance of this spatial data and the local data, because however urban heat happens, it affects individuals differently. And I think that's where this understanding of the spatial differences and the vulnerabilities that have an impact on how people are affected, and not just the climate data. Thank you.
Are there questions from the audience?
Hello, thanks very much. My name is Werner from Ireland, and I have a question, I suppose, arising from Clemens, your presentation, and for Tuukka, I guess, as well. I used to work at Mace Head, and you probably know where Mace Head is, and one of the projects there was the A-Gauge project, and it was run by Peter Simmons with the University of Bristol, and he was able to look at the CFCs in terms of what's happening to them in the atmosphere, and he was able to say essentially used to say to me about how his pollution peaks were disappearing, and that was, I suppose, the first indication of effectiveness of policy. Now, the policy we're looking at here is on climate, and Clement, you mentioned the peaking of greenhouse gas emissions and then a reduction. And I'm wondering, are there products either from space-based or in-situ observations that can help us observe peaking of emissions, either through pollution measurements in situ or from space? And I suppose I'm thinking of not the dramatic trend, which will take a while to appear, but more in the noise, so to speak. And I wonder, is there, I suppose on this specifically, are there something from what we saw during the COVID period that can help us pick out something that can help us in that area?
Perhaps the first reaction to that, and I think it was from the colleague Lars Peter at WMO in a panel where you were there, Werner, as well. By definition, we will know that it has peaked after. So we have satellite Earth observation that probes the atmosphere and that permit to provide column concentration of greenhouse gas, and we combine them with atmospheric model to try to track the source of pollution. So if we put that together with the dense network of in-situ measurement we have, not everywhere, we will be able to know when this will have happened. Yes.
Maybe I can also make one comment on this. And the peak will not happen everywhere at the same time. So we need local information to see, is the city of Nairobi peaking? Are the emissions going down there, or perhaps some other processes crucial? And the city of Berlin or New York might have a different time of peaking. So definitely there we need local information. We will perhaps also have a global peak, average peak, which we might see with background information and also inventories, but I don't think that we will have only one peak. We will have many peaks. But Niina, did you want to say something? Or Tuukka? Yeah.
I can say a little bit continue on Werner, what you're saying about the spatial variability in peaking, and it actually it's also true that depending on the greenhouse gas or CO2 has a very long lifetime, so it will peak much later than the air quality parameters. And of course the reduction of CFCs and the related Montreal protocols, etc. That's a showcase for showing that policies have an impact. And in air quality, we've seen globally that SO2 concentration is going down. So there's improvement to be seen, but it will have very high spatial variability. So comparing the cities and the regional background as well. This is I would say that showing the long-term data with this perspective is to give hope to people that we actually are doing improvements, but the timing and the spatial variability need to be taken into account. Thanks. Very good question.
There were two more questions. Yes.
Yeah, my name is Tanda Godwin. I'm a leader of an NGO, an environmental NGO in Cameroon. I'm really impressed with the quality of presentations by the panelists, but I have some concerns to raise, and these are more on, I understand the universities, the data centers are generating quite robust data for different climate occurrences, like you talked about heat, you talked about floods, and when he posed the question, who are your beneficiaries, and you talked about the policymakers and you talked about the citizens. Now I have maybe I have a worry that there is some kind of disconnect because we focus on people that are living in the city. What about the people that are living in the rural areas? And if you generate data, probably data that will help maybe people that are living in the remote areas, in fishing ports, people that are living in the city, that the decision makers, the policy makers are going to have your data in terms of report. Now, how then the citizens or the remote dwellers have this information to be able to respond? And how, and what is the interval of your data provisions? For example, in the heart of the rainy season, we are expecting floods. The people need this information to react quickly. That's providing timely warnings. So I want to really understand how you get this information to the beneficiaries, to the people that are facing these climate risk challenges.
Thank you very much for this question. The satellite Earth observation can see everywhere when it is difficult to access the pole, the mountains, the ocean, the desert, and also area where we don't go anymore. You mentioned war zone. We are working on fragility and security as well. We are, for example, with the war in Ukraine or the situation in South Sudan, we have analyzed the impact of this on food security and the impact from war and conflict on the production of agricultural goods. So, but then it's also a question of mandates. Is it the mandate of a climate service to go until citizens, perhaps, or should it go to decision maker, and then it is to the decision maker, based on this information, to reach their people. And this can happen everywhere. We had floods, very big floods in Europe, in Belgium and Germany, about 3 or 4 years ago. We have forecasted them. We knew that. We had an uncertainty associated to the risk of having flood. It happens, and there were a lot of casualties because this information was not brought to the last level of people, and we need to do this last miles. But perhaps this last mile has to be done at regional and local level.
There was
good evening, everyone. Thank you very much for your great presentation. I really enjoyed this local and global kind of mix of a point of view, and your research great. So I'm coming from another perspective because I'm a comparative lawyer. I'm an international lawyer. I work at BICL, the British Institute of International Comparative Law, Ivana, by the way. And so my question is about the fact if we can use all this great research, the database on climate risk, the ESA work, also what you're using in your research, Joyce, Tuukka, Niina, all of these regions, can we use for this kind of litigation? We are working on climate change litigation, particularly involving business in this moment, involving corporations. And I believe that attribution science, as we've seen, is advancing. But do you think that we can use this kind of research? And it's also an invite to all of you to, I'm extending an invite to join our global practical toolbox on corporate climate litigation that we are developing. We have great scientists also. We have Joyce, that is part of our Kenyan delegation. We have Rick Heady, that was one of these geographers that created the Climate Accountability Institute. So, giving a percentage of each, carbon major of the responsibility. So can we use also your help? Can we use also your data, your research to bring this kind of other tool, because we're talking about toolbox, for improving our climate governance? Because as Tuukka said, we had the Montreal Protocol, success story, but we are here since 20 years and more, and as you know, global stocktake, we are not doing enough. So this is my question. Thank you very much.
That question, I think by default it comes to me first before it can go to other people, if you guys don't mind. Definitely for me, really, it's been just doing science, but also really ensuring that science is meaningful for other policy processes. And I've been very keen on seeing that the science that I do can actually support climate governance, which is, I think, is important. And I have been involved in this field of attribution where I try to understand, for any particular event that happens, what can we say about the role of climate change? And just really the emission of greenhouse gases in the atmosphere that is causing the warming of the planet. I try to understand what kind of modification is that, are those greenhouse gases on extreme events that we're experiencing, and particularly the impacts that our people are feeling, felt by the people. So, and I think it's important to have the science actually inform processes like climate litigation, because we're sort of providing the evidence of saying it's important that we advance climate governance in a way that science can support it. So we have the evidence, it's grounded on the data, on the research, and we can provide a compelling evidence to say, I think we're not in the right direction. Some of the activities that we're doing as humans are actually hurting other people, they're causing suffering to other people, and all of us should be, the responsible people should be held accountable.
Thank you very much. We have to wrap up. We will be kicked out soon. I would like to summarize very quickly. I think the services we have been speaking about, they have to be very comprehensive and integrated. That's the first conclusion I draw from this panel. But also that there are many knowledge systems they have to integrate it to provide all these comprehensive services. My final word is, why is ICOS making a panel like this? ICOS is a research infrastructure, a European research infrastructure that is working on the very high technical level. And we provide very accurate data. And we have been in the process for the Global Greenhouse Gas Watch from the beginning. And we have been identified somehow as a blueprint because we have a well-developed data life cycle and so on. But I think we cannot transfer what we are doing one-to-one to every region in the globe. And that's why we want to listen. We want to listen. We want to turn around the idea of observations and start from the services. And we want to listen how we can develop a good global greenhouse gas watch with also ideas and approaches that are different to ours, because ours is super expensive. And I think that's why we, from the ICOS side, have also are running a project with African countries, but we really want to listen what could be the best design for greenhouse gas observations globally. So for me, it was a very good lecture also. Thank you very much to the panelists. Thank you very much to your questions from the audience. And with that, I conclude this side event. Thank you very much.